Hi and welcome to your Maths 1 students. We're going to look at differentiation in this tutorial, and I've decided to cover the questions pertaining to differentiation from the June series of the 2021 Cambridge examinations. So here we are in June, paper 1-1, 2021, and what I'm trying to do here is find the equation of the normal to the curve at this point here, and I have to give it in this form here, and here's my curve. So I'm going to rewrite y as 2 bracket 3x plus 4 to the power of 1/2 minus x, and then therefore dy dx. I'm first finding the gradient function. That'll help me to be able to find the gradient of the normal. So will be equal to now I take the 1/2, I multiply it by the 2 and by the 3, so it ends up being 3 in front of the 3x plus 4, and I drop down the power to minus 1/2. So just to clarify, I take this half, I times it by this 3 and the 2 that we've already got in front of us there. So that will give me overall 3 at the front, and then I drop down the power of the bracket. You can use the chain rule and do all the steps, but it's good if you can kind of get proficient at doing it without that. And then differentiating the minus x, it gives us minus 1. Now, the gradient of the tangent at 4, 4, this will give us 3 over 3 times 4 plus 4 to the power of 1/2. Minus 1, which gives us, now on the bottom you've got 3 times 4, which is 12, 12 plus 4 is 16, screw it, 16 is 4, so 3/4 take away 1, and so that will be a negative 1/4. That's a bit messy, isn't it? So negative 1/4, and therefore the gradient of the normal is going to be the negative reciprocal of that, so 4, because the gradient normal is perpendicular to the tangent at that point. So there we go, that's the gradient of the normal. At this point we can now use this. So we've got y equals mx plus c. So we can just chuck some stuff in there. We've got y is 4, we've got m is 4, we've got x is 4 plus c. So 4 equals 16 plus c. So it looks to me like c is negative 12. So therefore our equation is y equals 4x minus 12. And that is our final answer for part A, all 5 marks. I think we've got all 5 marks there. Find the coordinates of the stationary point. Now we know that the stationary point occurs when dy dx equals 0. So I'm going to write this as 3 bracket 3x plus 4 all to the power of negative 1/2 minus 1 equals 0. And I'm just going to rearrange this. So I guess we can rearrange it so 3 equals 3x plus 4 to the power of 1/2. So I've skipped a couple of steps here. I moved the minus 1 across the right hand side, and then I times both sides by the 3x plus 4 to get rid of it from the bottom of the from that negative power. Okay, so that's what I've done there, and then I'm going to square both sides, so I should get 9 equals 3x plus 4. And therefore 5 equals 3x, and so x is equal to 5 over 3, and y equals, now I can just plug this into the original equation up here. So when I do that, what do I get? 2, whoops, turn the calculator on, 2 bracket, no, what did I say it was, 5 over 3? 3 times 5 over 3, that's 3, plus 4, and then just go minus 5 over 3, and I'm getting 13 over 3 for that, so y equals 13 over 3. So coordinates are 5 over 3, comma 13 over 3, and done. Determine the nature of the stationary point. So a couple of ways of doing this. I'm going to find the second derivative. So I'm going to differentiate the dy dx. Now this is dy dx there, isn't it? So that 1's going to drop out. We take the negative 1/2, we times it by the 3, so this times this times this. So I think we're going to get negative 9 over 2 as our number in front of the bracket. Then the bracket itself, that whole bracket is going to drop down by a power, so it should be negative 3 over 2. Now, at x equals, where was our stationary point? 5 over 3. That's just the fire alarm. Hopefully the house is not on fire. Apparently not. Equals negative 9 over 2 into 3 times 5 over 3 plus 4 all to the power of negative 3 over 2. Now, what does this give us? 3 plus 4 equals to the power of negative 3 over 2 times, what are we getting? 3? 5 plus 4, so 9 to the power of negative 3 over 2, and we're going to times that by negative 9 over 2. Now I'm getting negative 1/6, and since that is a negative, therefore we know that we have a maximum point. Perfect. So that's all of the questions for the June paper 1-1, all the differentiation questions. Now let's move on to June 1-2. And okay, so we've got okay. Well, we've got this gradient function here, and we know that we've got a stationary point here, and we've got to find k. Oh, that means if there's a stationary point at 2, that means that 6 bracket 3 times 2 minus 5 all to the power of 3 minus k, which we don't know, times 2 squared should be equal to 0, because the stationary point, the gradient function, is 0. So what we get here, 3 times 2 is 6, 6 take away 5 is 1, 1 to the power of 3 is 1. So we get 6, and then we can bring equals 4k over to the other side, 4k squared, no, wait, just 4k. And so k is equal to 6 over 4, which is 3 over 2, and we're done there. Okay, now we've got to find the second derivative. Okay, so we're going to say we've got dy dx is equal to 6 bracket 3x minus 5 all to the power of 3 minus 3 over 2 x squared. And if we differentiate that, let's just consider this first bit here. So we're going to go 3 times 3 times 6. So that's 54. And then we're going to drop that whole bracket down by 1 power, so it should be squared. This thing here, the 2 times negative 3 over 2, so that will give us negative 3x. And that should be our answer for the second derivative, and that's all we need to do there. Determine the nature of the stationary point. Okay, so now what we can do is we can take that 2 and pop it into the second derivative that we've just found. It's going to be 54 bracket 3 times 2 minus 5 all to the power of 2 minus 3 times 2. Now what does this give us? well, 3 times 2 is 6. 6 minus 5 is 1. 1 squared is 1. So we get 54, take away 6, which is 48. And since this is a positive, we're going to have a positive, so a minimum point. Okay. And what else have we got? Oh, this is an interesting one. I've got an equation of a curve, and we've got points lying on the curve, and we've got some non-exact values rounded to 4 decimal places. Okay, find k. Okay. Well, what we can do is we can plug in 2 into the equation to find our k value, which is a y value. So when we do plug that in to the calculator, what do we get? Times square root 3 plus 3. I'm getting 1.2679. Sorry if you can hear some crying in the background. That's my tantrum throwing 3-year-old. My apologies. Now find the gradient of AE. So the gradient of AE is going to be changing y, changing x. So we're going to go 3 minus k. I'm going to use my unrounded number from k, so I'm going to save that. Over the y, which is 3 minus 2. Now, this is 3 minus, now k was 3 minus square root 3, so we're taking that whole thing away, all over 1, which is equal to, well, just square root 3, which is 1.732124 decimal places. Now, the gradients of BE, CE, and DE rounded to 4 decimal places are 1.9748. So, BE, CE, and then DE. Right, those respectively. And we've got a state giving a reason what the values of the 4 gradients suggest about the gradient of the curve at point E. Now what you'll notice is, like at A, the x value is 2, and we got a gradient of this. Then we had 2.9, and we get this gradient here. 2.99, so closer again to E, which is 3. And you've got this gradient here. And then really, really close, like 1/1000th away from E, and we get this gradient here. So you can see as we get closer and closer to, as the point that we're drawing a tangent from, or finding the gradient from to E, gets closer and closer to E, as that distance between those 2 points is smaller and smaller, the gradient seems to be approaching 2. So what could we say? The gradient at point E seems to be 2. And the reason for this is, as the points get closer to E, the gradient approaches 2. And I guess we could use the limit terminology that we are thinking about with differentiation. The gradient at E is, and the gradient at E I guess it gets closer to, okay, so we could say maybe something like as the distance between E and the other point approaches 0, comma, the gradient tends to 2. Okay, now probably, look, as you know, I'm no great mathematician. I've only had to learn this stuff in the last couple of years. You probably want to just check the mark scheme for the kind of word or the language, words or language that they're going to use here. All right, so that looks like June 1-2 stuff. June 1-3, what have we got here? The function is defined by this stuff here, and it can go up to a, and it's a decreasing function. Okay, a decreasing function. So we've got to find the maximum possible value of a. Okay, so if it's a decreasing function, that means that the gradient is negative. So let's find the gradient function. 3/2, so we're going to do this times this times this. So 3/2 times 2 is 3. 3 times 1/3 is 1. Okay, so that means we'll have a 1 in front of the bracket, which means we don't need to put it in. We're going to drop the whole bracket down by a power, and then that minus 2x becomes minus 2. And decreasing function means that 2x minus 1 all to the power of 1/2 minus 2 is less than 0. So what we're going to do is we're going to move that across to the other side. It's less than 2. And so 2x minus 1 is less than 4. And I guess we'll have to come up here. And 2x is less than 5. So x is less than 5/2. So that means that a equals 5/2. That's the maximum value it can be. All right, well, that was all right. Let's move on. What have we got here? The diagram shows part of the curve with this equation. And we've got to find the coordinates of the minimum point. Okay, so we're going to differentiate. And, okay. So I'm going to take that half, times it by the x, drop the power down by 1. I'm going to take that negative half for the next term. I'm going to times that by the k squared, and then I'm going to drop the power down by 1 again. Minimum point occurs when that equals 0. So I'm going to go half x to the minus 1/2 minus 1/2 k squared x to the negative 3/2 equals 0. I'm going to move, I'm going to rewrite it like this, and then I'll pull that k squared one across the other side, so I get k squared x to the power of negative 3/2. I'm going to times both sides by 2, so I'll get 1 over square root x equals k squared x to the negative 3/2. Now I can times both sides by x to the negative 3/2, x to the 3/2. So I get x to the 3/2 over square root x equals k squared. And that will mean that I get k squared is equal to actually 1. Sorry, is equal to 1, is not 1x. Right, there we go. So that's the coordinates in terms of k. So that's the x value. Now the y value, I'm going to put it in this x value of k squared into this formula here. So I'm going to get k squared to the power of 1/2 plus k squared multiplied by k squared to the negative 1/2. Now that turns out to be k plus actually k, or 2k. So hopefully you can see how I got that. Let me just back up the truck a bit. This bit here, multiply 1/2 times 2, so that gives us a k. This bit here, k squared times, now what's k squared to the power of negative 1/2? That's k to the negative 1. And k squared times k to the negative 1 is k to the 1, which is k, and that's how I get that. So the coordinates are therefore k squared, comma, 2k. Lovely. So the next one, the tangent at the point on the curve where x equals 4k squared intersects, we don't have much room here, do we? Intersects at P. Okay. Okay, so find the y coordinate of P. Okay, so what we want to do is find the gradient at when x equals 4k squared. So grad at x equals 4k squared. So we're going to chuck that into this equation here, dy dx equation. Okay, so that's what I'm going to try and do now. I'm going to go 1/2, and then I'm going to go 4k squared to the power of negative 1/2 minus 1/2 k squared to the power of 4k squared to the negative 3/2. Now, what does this work out to be? So we get the 4 to the negative 1/2 is 1/2, so 1/2 times 1/2 is 1/4, and the k to the negative 1/2 is k to the negative 1, and that's right, isn't it? And or 1 over 4k, and the next one is what's 4 to the power of negative 3/2? So that's like, I think it's 1/8. Let me just, negative 3/2. Yeah, it's 1/8. So it's 1/8, and then I'm going to times that by the 1/2. So that should be 1/16. Now let's look at the k's. K squared to the power of negative 3/2. That would be k to the negative 3. And then I'm timesing that by k to the 2. So I think this should be k to the negative 1 as well. Okay, so therefore the gradient is going to be, all together, we can just add those together, can't we? That's 3/16. Whoops, sorry, messy. Not k to the negative 1, or maybe we'll just go 3/16k, like that. That's probably nice. Now, the y coordinate at x equals 4k squared equals, now I'm going to pop that into the original function here. So so that's this bit here, x to the power of 1/2. So 4k squared to the power of 1/2, and then we're adding k squared, and then the x, which is this 4k squared, and that's to the power of negative 1/2. Okay, now we just try to find the y coordinate for where the tangent starts. So that will give us 2k plus, now this one is going to be negative 1, so 1 over 2k, 1 over 2k, so I think this should be k over 2. And I guess if we put that all together, we get 5k over 2. Okay, now what we've got is we've got the coordinates, both the coordinates here, and we're doing a tangent, and we're trying to see where it touches the y-axis. So we want to find that y coordinate there. So we're just going to go y equals mx plus c. So y equals m, which we found to be 3/16 k. Mx, now x is 4k squared plus c. And we've got to find out what plus c is, because that's the y-intercept, which is the y-coordinate of where it intersects the y-axis. Okay, so that's what we're trying to do. So 5k over 2 equals, what do we get? 12k cubed over 16. And plus c. Okay, so we can go 5k over 2, and minus, now we can rewrite that as 3/4 k oh, hang on a second. I think I've made a little bit of an error here. M? Yeah, I have. That, okay, so I'll just point out where I've made the error. I stuffed up my gradient here. That should be at the bottom, shouldn't it? So let's just fix that up. So that should be over 16k bracket. Now when we do that, that will mean we won't have 12k cubed, we'll have just 12k. Alright, minus 3/4, and so we need to get rid of this cubed here. Okay, equals c. Now that's a bit better. Equals to c. Now I guess we could make them both into quarters, so 10 quarters take away 3/4, so I think it should be 7/4. Oh, that's messy. C equals 7/4 k. And that would be, I guess that would be the answer. That's your y coordinate. Maybe I'll just make that clear for the examiner. Y-intercept of tangent at x equals 4k squared. Or p. Alright, that'll do. Alright, hope that's been helpful to you, team. And take care, God bless.